Going on, my dudes? This is Matt Time with Mr. G, and today we're going to talk about dependent versus independent in probability. First, we're going to talk about what sample versus population is. So let's say that there are 300 kids at school, and I only interview first graders, so only 30 of the 300. So since I selected a group of people, that's a sample. If I interview all 300 people at school, that's a population. And a random sample means I don't know which grade they're in. I don't know if they're boys or girls. I don't know if it's teachers or students. It's 30 random people. But if I do a select group, first graders, something like that, that is a grouped sample. They all are in the same category. Dependent versus independent events is, let's say I have a bag of marbles and they're all different colors, and I take one bag out or one marble out, I see what color it is, and then I put it back in, and then I redo this experiment 5 times in a row. Okay? Those are independent of each other because it's the same experiment on repeat because I put it back in. Dependent would mean I have a bag of marbles. I take one out and I leave it out. So it went from 4 marbles down to 3. Then I take another one out down to 2. That's dependent because the experiment changed every time I take something away from it. Theoretical versus experimental is I flip a coin. There are 2 possibilities of me flipping the coin. It's either heads or tails. So I flip this coin 100 times. I would expect 50 times for it to land on heads and 50 times for it to land on tails. I actually flip it 100 times, and it turned out to be heads 52% of the time and tails 48% of the time. Does that mean my coin's broken? No, it just means that I need to flip it more. If I flipped it, let's say 10,000 times, the more I flip it, the closer it'll get to 50-50. So theoretical is what should happen. It should be 50 and 50. Experimental is what actually happened when I did the experiment. Then I can compare the experiment to the theoretical and see if the coin is broken or rigged and the person's cheating or not. Probability is what we want to happen divided by what could happen. So let's say I wanted to land on heads. Okay? So heads, it landed 52 times. What could happen? I flipped it 100 times, or 52% of the time was the probability for this example. Let's say I want tails, then it would just be 48 out of the 100. Outcomes is the total things at the end. So let's say I had 2 pairs of pants, 5 shirts. How many outfits could I put together? Well, I could have pant 1 with shirt 1. I could have pant 1 with shirt 2, and so on and so forth. Then I could have pant 2 with shirt 1, and so on and so forth. So it's how many things could happen is the number of outcomes. So let's see number of outcomes for, I have 2 shoes, 3 shirts, and 4 pants. So what I do is I just multiply all these numbers. So 2 times 3 is 6, times 4 is 24 total outfits, or total outcomes from my decisions. So 24 people could make 24 different outfits. However, if we're talking about a reset, so I am spinning the wheel, it has 3 colors, and I spin it again, the probability of getting a different wheel doesn't change. So the outcome is going to be 3 to the power of 5, because there's 3 choices that could happen. Then I spin again, there's 3 choices that could happen. Then I spin again, 3 choices that could happen, and so on and so forth. and 3 to the power 5 is 243. So it could be, let's say, red, red, red. That's one outcome. I could have red, blue, red, and I could have blue, red, red. And because this blue has moved locations, that's a different outcome. If we care about the order, this matters a lot. So that's why there's 243 different ways that the colors could come up. So even though this only shows blue coming up twice, there's 243 different combinations. Other than that, be kind to one another, ask lots of questions, and think deeply.